Assalamualaikum warahmatullahi wabarakatuh. Hello, we are 5A group from wastewater treatment process course, Environmental Engineering Department, UPN Veteran Jawa Timur. I will introduce my member group. From me, I'm Uci Vida Fitriani, and my friends Franciscus, Immanuel Mintarjo, Erwin Kurniawati, Adhelia, Salwa, Sokhil, Ababiluna. Okay, we'd like to present our assignment biological treatment, anaerobic digestion. So what is anaerobic digestion? Anaerobic digestion is the most common sludge treatment, may be defined as the biological oxidation of degradable organic sludge by microbes under anaerobic conditions. Anaerobic digesters are usually constructed using cylindrical reinforced concrete tanks from 12 to 55 feet deep and from 15 to 125 feet in diameter. In common, anaerobic digestion has two-stage anaerobic digester system. Wastewater treatment facilities use both conventional and high-weight anaerobic digesters to reduce volatile solids in wastewater treatment sludge. The differences between them is velocity, there are several types of commercial anaerobic reactors such as CSTR, anaerobic filtration, UASB, and expanded bed reactor.
Okay, conventional anaerobic digestion process with 4 stages of settlement in the following figure. The first stage is hydrolysis. This stage is the process of breaking down complex organic materials such as fats and polysaccharides into simple organic materials such as glucose and fatty acid with the help of hydrolytic bacteria. The second stage is acidogenesis. At this stage, glucose and fatty acid produced in the hydrolysis process are converted into organic acid, alcohols, and ketones with the help of fermentative acidogenic bacteria. The third stage is acidogenesis. At this stage, the higher organic acids, ketone, and alcohols produced by acidogenesis are further digested by acetogenic bacteria to produce acetic acid as well as carbon dioxide and hydrogen. This group of bacteria requires a low hydrogen voltage for fatty acid conversion. The final stage is methanogenesis, which produce methane by two groups of methanogenic bacteria. The first group is called acetate splitting, which convert acetate to methane and carbon dioxide, and the second group use carbon dioxide as an acceptor electron and hydrogen as a donor electron to produce methane. Next.
Okay, in here we have type of wastewater characteristic. The type of wastewater and its characteristic are important in the evaluation and design of anaerobic process. The characteristic presented here is sludge playing, attached growth, and membrane separation anaerobic process presented in subsequent section. Important factor and wastewater characteristic that need to be considered in the evaluation of anaerobic process for wastewater treatment are discussed below. We can see in figure 2.1 example of type of wastewater treat anaerobic process. Next. We have removal efficiency. According to MDWW or molasses distillery wastewater, in one of studies treatment of melanoidin wastewater by anaerobic digestion and coagulation, waste zone removal efficiency are obtained. We can see in the image. Next. We have advanced and disadvanced. First, I will explain about advanced. 1. Methane recovery by most of the microbial biomass product in aerobic growth or biogas. 2. reduce production of landfill gas. 3. Sludge occupies less volume, easier to dry. 4. Lower operating costs. And 5. Odor or flies typically removed from system. And I will explain about disadvantages. 1. Accumulation of heavy metal and contaminant in sludge. 2. Narrow temperature control range. And 3. Installing and managing an interrelated group of systems to safely handle heating of the tank, hydrogen sulfide reduction, methane transfer, heat production, electrical production, interconnection with the electrical grid, and surplus heat management. Next.
And now I will present about how to operate an anaerobic digester unit. In this presentation, we'll use the sludge stabilization with anaerobic sludge digester. The step is first, the operation of the sludge digester is carried out at operating temperatures of 35 to 55 degrees Celsius. And then the filtered substrate is flowed into the anaerobic sludge digester unit. And furthermore, the incubation process by thermophilic bacteria can increase the rate of processing in the digester to a higher level. And the dry sludge, called sludge cake, from the processing of domestic wastewater sludge after going through the digestion process is already in the form of humus. So it can be used as a soil conditioner and can be used as a landfill. If there is a concern that the mud contain heavy metal or battery, it should be used as landfill on which plants are not planned for human and animal consumption. This is a remediation method. And for the maintenance, there are two conditions. The first one is if the flow is smooth and the amount of water coming out again means the slope of the pipe is correct. Perform a flow test also from the septic or a flow filter to the infiltration area. And the second condition, if the flow is not smooth, slow or stops, it means there is a problem with the piping system, then it needs to be repaired. And there are two factors that need to be considered before we do the maintenance process. The first factor is the digester will start too quickly, and the second, excessive volatile solid due to erratic feeding or change in the composition in incoming salt solid. And the third, the load of volatile solid exceed the load limit, namely more than 10% per day. And the fourth is lack of effective volume in digester due to accumulation of sand, which prevent inadequate mixing. And after that, we can do the maintenance process that need to be done is solids must be removed or removed from the primary digester prior to the sludge treatment process. Then the solids should be removed at least daily to avoid decreasing the population of active microorganisms. And the primary digester can be set to flow to the secondary digester or to a sludge storage tank. Then the solid can be removed from the following location. First, the bottom of the digester, and second, overflow section, and every point in digester is mixed. And the removal of solid from the bottom of the digester is better because it can reduce the sand accumulating at the bottom of the digester. If possible, collection of solid should be carried out periodically so that the sludge treatment process can run well. And here is example technology by Enviromix that name Biomix 80 is a compressed biogas mixing system provide mixing of anaerobic digester tank contents by firing operator program. Short duration high velocity bursts of compressed biogas through patented engineered bubble-forming nozzle located near the floor of the tank. The biomix system power utilization is efficiently applied across multiple tank systems by using a single optimally sized and easily maintained compressor with further optimization realized through adjusting the nozzle header firing parameters. Biomix system provide significant power saving as compared to mechanical or pump mixing system by uniformly distributing mixing energy across the basin floor rather than directed outward from localized point in the tank. Studies have documented 60% plus reduction in the power usage versus alternative mixing system. Results have also demonstrated biogas production increase over 20% plus versus alternative mixing technology. For the product review, you can visit the link we provide in the presentation slide. And that's all from our presentation. Thank you.